how to continue for program 5b. All right, let's look at our assignment quickly and pick up on what program 5b is about. So we see that in 5a, what did you end up doing? Your job was to build the carlot3.cpp file. And when you did that, you discovered that you had to call the member functions of the automobile class, and you were able to do that within your main. For part B, your job is to complete the bodies of the carlot3 functions, and those are basically the searches and the sorts that you need to do. If you did the sorting video, you saw that I pretty much gave you algorithms for bubble sort and for selection sort. I gave you algorithms for linear search and for binary search and all those guys. And if you had done the drills, you would have seen, you probably would have constructed code that search and sort what we call scalars, that is arrays whose data type is just a scalar, a single integer like an int or a float or a string. So let's take a look at what is required for this program. So let's take a look at the carlot functions. All of this is in the starter carlot3 functions, and it looks like we have one sort where we're sorting ascending based on the MRSP attribute or data member of the automobile class. We're sorting in descending order based on the MPG and in ascending order of odometer. You may use either the bubble sort or the selection sort in your sorts. So basically, most of these sorts, if you have one sort routine, you can adapt it easily to handle all three of these cases. You also are required to do these functions called pick. And what is pick? Pick is like you must walk through the full inventory, which is array C. And every time you hit a record that meets the criterion, like the year that you're looking for, you store a copy of this object into another array called picked. So you may start off with 10 cars in C, no cars in picked. The first car that you find in C, you're going to store it in picked sub-0, and you're going to increase the size of non-picked. The next car that you find that matches it, you're going to store it into picked sub-1, and you're going to increment number picked. So that's basically all you do by both of these. Now, pick by color is a little trickier because you got to know something about the string function called find. I've covered this in the past, and it's up to you to find that. So if you want maximum points, you got to figure this one out. Now, you also have in this file some examples of going through all the cars in the array, which is what you got to do for all these functions above. All right? So you get a feel for what you need to do in all of these instances if you just study that very carefully. All right? Now, let me tell you what I've given you. I've given you a program called sort by data type. And in it, I have shown you how to sort in the simplest case. I have not shown you how to sort. I have shown you how you do the basic sorting step. And the basic sorting step is simply to compare two entities based upon a particular field and making a decision whether or not it's necessary to swap rather. So in all sorting algorithms, you need the ability to swap. Here's the first swap where we're just swapping a simple integer. They must be passed by reference. So if I have two integers, I swap them like this. If I have a data type, which is a struct, defined by a struct, then notice the algorithm is totally the same. The data types are different, but everything else is totally the same. Suppose I have a data type that's defined as a class. What does the swap look? It looks totally the same. All right? So you need a function called swap. All right? Now, in the main program here, I'm demonstrating what's involved if I wanted to compare the first and third elements. If the elements that we're looking at is a field of a struct, then how do we do this? So in this case, we're declaring an array of 5 records. The first record contains in the A field a 9, in the C field the string NINE, and so on. And now we want to compare the third element, which is this, with the first element. We're going to compare it based on the string field. So, and the rule is if this string field in the third record is bigger than the string field, corresponding string field in the first record, we want to swap the records. So that when we're all done, we want the first record to be this and the third record to be that. And so the code for doing that is simply what? Is this. If the C field of the third record is greater than the C field of the first record, I want to call a swap. I pass the whole record SV sub 2, the record SV sub 0. And this will accomplish the swap. So in case you're using the bubble sort where you compare two neighbors, you will basically say these subscripts would be neighboring subscripts. So one might say K and the other K plus 1. All right? And what if the data type is a class? Notice here about the class. We have a class, we have constructors, we have the ability to get the string field, str, and we have the ability to show everything, all the data values within an object. So here, what are we doing? We're declaring an array of 5 objects, C1, C2, C5, C4, and C3. And the second one is C5. So what does C5 look like? The second word is the French word for 3. And the first one is the French word for 8. And this word is bigger than this word, so you would expect that we would swap these two elements. So if I were to print out the second element followed by the first element, it should be this element comes out first, this element comes out last. Okay, so why don't we just run this and see what it looks like when you run it. So we're going to say, what's the name of this thing? Sort by that. So let's do, if we just did scalars, we would see that the third and the first are 7 and 8, and we don't do a swap. If we do the same thing and say 2, we have a struct 3 and 3 and 9 and 9. Are these out of order? This is the third one here. Yes, it's out of order, so we should swap it to have that. And finally, if we run this and give it objects, we have an object that consists of 3 and the word trois, 8 wheat, And here's the third one, here's the first one. Is this one bigger? Yes, so we should swap. What's going on here? The word. This looks funny. Okay. Okay, now what is the point of this? If you take a look at the code that I have in this program called sort by date data type .cpp, it'll basically give you some hints about how you would go about sorting when you have an object. I guess I need to show you one thing. My bad. Gotta show you this. The important thing to note, let me just get to it, is if you have a class, what do we see up here? If you're going to sort based on the string private variable, you need to make use of the getString function to get a value for it. That's the main thing you need to know. Okay. Now let's look over here and see if is that any different. Well, that's no different from here, is it? Because I say take one of the objects, object sub k, and find out what the sold field is by calling this function. Here I'm saying I want to have this object c sub k. I want to get the value for this field. So you'd be doing the same types of things using these calls up here in the place where you make the comparisons for sorting. Okay, with that I want to shut down. I need to remind you that this is really not a difficult assignment. All you're doing is putting in sorts here. You're going to put in a search here where you go through and build a whole new array. That's all that's required. So good luck.